My name is Dylan Weekly and I'm an urban planner at the City of Johannesburg Metropolitan Municipality. I also have a special interest in GIS and Earth observation, and I'm busy studying part-time towards a master's in GIS and remote sensing at the Wits University here in Johannesburg. The City of Joburg does use Earth observation data, but we certainly need to expand our capacity in this field, and that's why we're very excited about this project. Much of the data or products that are available to us generated through Earth observation data are available commercially, so they're difficult to procure, but also very expensive. We also have a lot of data available for integration with Earth observation data, which we believe is underutilized, and have included some examples here: administrative data, including our town planning application system, etc. We also collect LiDAR and 15-centimeter resolution imagery every 2 years for the whole city, and we believe that is a very valuable resource, but that's also a bit underutilized at the moment. And I've included a quick example below of how we have used Earth observation data in our planning. So as a part of the spatial development framework for the city, we created an urban potential model. We divided the city into these 400-meter hexagons corner to corner as a sampling method, and you can see here that basically sort of covers a soccer stadium. We also used the road network to measure what is accessible to each of these hexagons in the city in order to prioritize for land use planning, but also for infrastructure development. And this green line here shows the service area of 2 kilometers walking area from this green or blue hexagon in the middle. We then needed to measure a whole lot of data about what you can access from each of these hexagons in the city by road and mainly on foot. And one of the big limitations we have in the city and in South Africa broadly is the location of jobs. We have quite good national statistics about how many jobs there are per city, but not within cities where the jobs are located. So we had to use a proxy for this. And we also do have quite good zoning data about where jobs are located, but it doesn't always pick up all the informal jobs and that sort of thing. So a company called GeoTerra Image creates this database and using very much Earth observation data. And this layer, for example, shows commercial buildings in the city. Using our hexagon model, we then measured how many commercial buildings are within 2 kilometers walk of each point in the city and came up with this heat map, which is the first step towards creating our model. Combining it with things like informal jobs, but also industrial jobs. This is the final jobs accessibility index that we created for the city. And then we combined them with various other sources of data. So this is a public transport accessibility index, education, capital spend, healthcare, parks. And those are all finally combined into the final policy, which is a land use policy that guides areas that are prioritized for intensification and densification, but also infrastructure spend. We've also published this online and it's available at that link. So going forward, we do see a lot of opportunities and interests for further work with this group. I've highlighted a few here. So we've got a lot of informal settlements in the city and a lot of informal development. So and informality resists formal data capture. So we see this as a great opportunity. We'd like to monitor sprawl in the city as we have been doing, but we think we could do it better. Take into account more environmental considerations, tree cover, open space, wetlands, etc. All of which we think this project could help us with, and certainly strengthen our SDG reporting. Thank you very much, colleagues, and I look forward to working with you.